right. Well, hi everyone. This is the first go at a podcast. Hopefully this will work out. We're going to be going over question number 9 from section 1.6. Question number 9 asks us this. We're going to be given a label. Has a length that's twice its width, less 2.5 centimeters. And it has a perimeter of 40.6 centimeters. And it's also given, this is a rectangular label. Given this information, can we find the width of this label? Well, the procedure in the textbook for section 1.6 is to try to solve these types of problems in 4 steps. The first step is to give labels for the different quantities in the problem. The second step is to come up with some kind of equation that relates these quantities together. The third step is to solve this equation for unknown. And the fourth step is to check our answer to see if it's reasonable. So for the first step, let's look at the quantities in the problem. Well, we're given that there's a length. Let's call that L. We're also told there's a width. Let's call that W. Finally, we're also told of a quantity called perimeter. Let's call that P. Now, what's important to do is to look at the label, specifically the quantity we're looking for. In this problem, we're going to be looking for the width. So we're going to want to keep that in mind throughout solving this problem. So on to step 2. Is there a way of relating these quantities together? One thing that helps with solving story problems is to draw a picture. So let's just draw a picture of a rectangular label. And on this picture, let's place the different quantities with the representative letters. We have a width, and a width, and a length, and a length. Now there's a way of relating these. Perimeter, if you recall, is equal to the sum of all the sides of the outside of a shape. In this case, perimeter will be 2W plus 2L. We're also given that the length is going to be twice the width, less 2.5 centimeters. So what that says, length is twice the width, and then less means subtract, so we'll subtract 2.5. Finally, what we'll do is we'll take this L and plug it into this L here to get an equation we can work with. Finally, we're actually given a value for our perimeter. It's 40.6. Let's plug that in too. Now what we have is we have one equation in terms of just numbers and then one variable W, the variable that we're looking for. This is what we're going to use to find W in part 3. So in part 3, we have 40.6. And let's expand this a little bit. We have 2W plus 2 times, let's distribute this 2. If we distribute this 2, we'll have 4W minus 2 times 2.5, which is minus 5. Now these here will add up to 6W. So 40.6 is 6W minus 5. Let's add 5 to both sides. We add 5. These 5s will cancel out. We have 45.6 is equal to 6W. We just have to divide by 6. We get W is equal to 7.6. So this is the answer that we've come up with. Does this actually match up with reality? Is this a good answer? Let's find out. If this is a good answer, then our perimeter equation with this as our width should still work. So we have 40.6 as our perimeter is equal to, let's see, well, we've got this equal to 2 times W plus 2 times the length. Now our length is 2 times width minus 2.5, or 2 times 7.6 minus 2.5. This is going to be 15.2 minus 2.5. It comes out to 13.2, comes out to 12.7. So with a width of 7.6, we're going to get a length of 12.7. So using our perimeter equation, it says that the perimeter is twice the width plus twice the length. Does 40.6 equal to twice our width plus twice our length? Well, let's run the numbers and find out. We have 40.6. Is that equal to, we have 15.2 plus 12.7, that's going to be 24. Comes out to 25.4. So does 46.6 equal this? Well, 15 plus 25 is going to be 40. And then 0.2 plus 0.4 is going to be 0.6. So it checks out. Our answer is good. And that's how you do number 9.